In this short video, I'll give a high-level, semi-technical description of how LLMs work. I'll use plain English without jargon, so you understand how the tools you use every day actually work, which should help you use them better. What is an LLM? I'm going to define these terms to help us see the big picture. An LLM like ChatGPT is a generalized pre-trained transformer. So what's a transformer? An AI transformer is really an autocomplete machine. To understand what a transformer does, you need to understand how autocomplete works. It's no surprise that the critical AI transformer paper came out of Google, where they had years of experience autocompleting billions and billions of sentences. Autocomplete is all LLMs do. It first has to understand that the user is asking a question. Now, it has seen billions of questions, billions of who is questions, hundreds of thousands of who is the narrator of questions, and hundreds of thousands of references to the words Moby and Dick occurring next to each other. It actually has no idea what's being asked. It simply computes the most likely next word given this arrangement of words. It doesn't even need the question mark to recognize a sentence. The most likely next word is the, simply because the most published answers to questions asking for a narrator start with the word the, followed by narrator. After looking at billions of who is questions, it sees that statistically the subject of the question forms the beginning of the answer. An answer like this is going to almost always be the same every time, even for different LLMs, because there just isn't much room for randomness. We can see where this is going, but the LLM can't. It simply gives the word Moby the highest score of what word that is most likely to come next given the question words. And this pattern follows the same pattern of many, many other answers it has already seen. One word at a time. It looks like it's thinking, but it isn't. It associates the name Ishmael with the word narrator because there are so many documents in its training set that have these two words very close to each other and in relationship to each other. So how does it do it? An LLM stores most of the words in the English language as vectors, which gives them a direction. The vectors seem random, but they begin to map out all the words in English. We store all the vectors as numbers in a giant database. We can see here that the green vector, which is computed, shows the relationship between male and female, and that same green vector shows up between words like king and queen, or buck and doe, and even bolt and nut. That green vector is a parameter. It's a numerical representation of something the LLM has learned about the relationships between words. Here's an analogy. In latitude and longitude, Boston is north of New York and Bern is north of Monaco. This shows that New York and Boston are close to each other on the north-south axis, while Monaco and Bern are farther away, but also aligned north-south. Right here, the green arrow at the top means north by 340 kilometers, and the longer green arrow means Bern is north of Monaco by about twice that distance. That will hold for all locations. The green arrow is a measure of north-southness. Similarly, there are billions of parameters that specify relationships between all the 100,000 or so English words. So even though this isn't a map, the vectors tell us a lot about relationships. This is a 3D representation of the data in an LLM. The vectors are the words, and parameters are the locations in that geography. This shows a three-dimensional space, but in fact, the words are stored in a 12,000 dimensional space because words are used in so we'll try to keep it simple, but remember, everything is thousands of times more complicated than I'm showing. So how does a transformer work? It figures out what a sentence means by computing its attention. Attention is what the words mean in context. To do that, the transformer looks at an entire sentence in parallel to understand what's important and what goes together. In this sentence, the tall man wearing the blue shirt was the shooter. We understand that there were several tall men, possibly, but only one was wearing a blue shirt, and this is critical to understanding the meaning. A transformer does this with numbers. This is an attention layer. Every single word has 12,000 numbers associated with it. That's a single number for every one of those 12,000 dimensions, and we don't know what they are, but this is an attention layer. Every single word has 12,000 numbers associated with it. That's a single number for every one of those 12,000 dimensions, and we don't know what they are, but they make some sense to the transformer. The attention processor takes one step at a time. Each step, it looks for one connection or one relationship that it can establish between one word and another word, looking for clues. One relationship is that man is a noun. Another is that it's the subject of the sentence. But it doesn't really know about nouns and subjects. It just knows patterns it has seen before. So the structure of the sentence emerges as it goes through each attention layer, one step at a time, and the transformer goes through about 100 steps, each step figuring out another piece of the sentence's puzzle. After about 100 steps, it has a numerical understanding of what any sentence means. And by the way, I didn't make these numbers up by hand. I had Grok do them. To predict the next word, you also need attention layers and the steps I just outlined. Add a few more steps and you get a probability distribution of what comes next. There's also some randomness built in, so in cases where the probabilities are close, it can choose a slightly less likely word, which gives it a less robotic feel, more natural tone. You can ask the same question and get different answers, but they shouldn't be too different in meaning. In this case, dog is the overwhelming favorite. There isn't a close second choice. 90% of most LLMs are dedicated to English words and 10% to about 200 other languages combined. Chinese gets about 2% and the rest have less than 10%. ChatGPT-5's command of French is world-class, so you can get a lot of language capability for less than 1% of what we use for English. Yet the LLM also recognizes that there are common patterns and structures between languages, so much of what it learns about English can be used for other languages. If you want to know what this says, just take a screenshot and give it to an LLM. In the exact same way, if we had about 100 times more whale or dolphin training data than we have now, and if some billionaire wanted to fund it, we could create an LLM that would be able to say the next click or squeal back to an incoming dolphin call. It would be able to pass the dolphin or whale Turing test. This is probably true of all animal species that use sound to communicate. The LLM would have no idea what it's actually saying, but it would be communicating, and they would think it's another one of their kind. An LLM has no rules, no syntax, and no expert guidance. It doesn't even know anything about punctuation. This is why AI researcher Frederick Jelinek said, "Every time I fire a linguist, the performance of our speech recognizer goes up." An AI can learn any language. If you train it on nonsense examples, it'll speak fluent nonsense. It could learn Klingon if you had enough Klingon text. No linguistics. It has to figure everything out by seeing enough patterns. It doesn't know any facts. It seems smart, and it's incredibly useful, but it doesn't know what it's saying. AI attention processing has to be done in parallel, which is why NVIDIA became the default chip supplier, because their chips process data in parallel and CPUs don't. So just because of attention, NVIDIA became the most valuable company in the world. Now I want to show you a couple mistakes to illustrate that this isn't perfect. This was a common mistake 6 months ago. Since 9 is greater than 1, most of them said 4.09 was greater. The only LLM that got it right back then was Claude. Now they all get it right. But the latest Claude almost always gets logic right, better than its competitors. I got this from Grok recently. It says, "I honed in on a key distinction," but that's an incorrect use of the word honed. It's not a hallucination. Grok meant to say homed in, which comes from homing pigeons, but this is such a common human mistake in the text it's trained on that Grok sees it as the natural next word. The more common a misconception is in training text, the more you'll see it show up in LLM responses. This is especially true in controversial areas where a lot of text is paid for by people with an agenda, or where a lot of people who write a lot of stuff are simply wrong. This is quickly leading to the industrialization of internet waste. Everything that's wrong about Wikipedia and Reddit is fast being repackaged and spewed out automatically, only to become the input for the next language model's training. It's still about gaming the system rather than finding the truth. This is not the enshittification of the web. The web was already shit. The proportion won't change, but the magnitude will. It's going to be enshittification at scale now. Training an LLM is a huge effort. LLMs are trained on billions of pieces of text in over 200 languages. It takes about 6 months to train an LLM. Grok 5 is training now and should be out in December 2025. GPT-6 is in development and may have begun training already. It costs between $1 and $2 billion to train GPT-5. But once you train the LLM, you have a model that takes less than 30 terabytes of data. You can get any of today's LLMs onto one of these SSD chips that fits into a camera. So the LLM product that results is fairly manageable. Once trained, it doesn't change. However, a recent paper showed a way that LLMs can just keep training every day, adding to their vectors and parameters without having to resort to expensive batch processing and starting all over from scratch, train a new one. This will soon eliminate the expensive training runs, and every LLM will simply get smarter and smarter and recompile every single day. Once you have the model, you can use it to answer questions or do tasks. Running an LLM is called inference. It's generally measured in queries, like answering a question. A query costs 20 to 40 times more than the same Google search. A Google search costs about as much as a grain of sugar, and an AI query costs about as much as an M&M, which is about a penny. The energy used is less than twice the amount. Most LLMs today include some native integrations to add functionality, and then they are wrapped with a web app or mobile app that gives you a chat window and a few features inside a browser window.